Earlier in the course, we introduced docstrings, which are strings that are used to create automatic documentation inside a function or a class. In this lesson, we'll introduce doctests, which are a lightweight test option. Now, these should not really be used for comprehensive testing. The goal here, much like with the assert statement in the previous lesson, is to get a general understanding, the general gist around the purposes of testing and what it is exactly the tests do for us. So what we're going to let Python do in this lesson is run some code automatically for us to confirm that our code works as expected. So the way that the doctest module works is it searches in our docstrings for pieces of text that look like Python expressions, pieces of Python code that are doing something with, for example, our function. We then have a test mod function on the doctest module, and it's going to execute those expressions that we have in our docstrings, in our comments, and it's going to confirm that the return values that we specified are the actual return values it received when executing the actual function. It's a lot to take in, so let's take a look at an example. So in this file, I'll define a function called sumOfList, and it's going to take a list called numbers. And right here, what I'm going to do is I'm going to begin by declaring a docstring. I'm going to do it with triple quotes. And here, I'm simply going to write my first actual docstring, my explanation or documentation for what this function is going to do. It's going to return the sum of all numbers in a list. And this is a regular part of a docstring, right? At this point, Python still doesn't have any understanding of what the function is going to be doing. We understand this from a human perspective, but the computer doesn't. But right down below, I can follow a very special syntax to actually use my doctest module, which we'll do in just a second. What I'm going to do is put 3 closing brackets, the greater than sign, if you will. And then what I'm going to do is invoke this very function. So I'm going to write sumOfList. And then I'm going to open my parentheses as if I'm invoking it. And remember, this is all within our docstring. So this is still a comment. We're just writing as if we're writing valid Python code. We're going to invoke sumOfList. And let's say I'm going to give it a sample numbers argument, a sample list of 1, 2, 3. Right below here, what we're going to write is our expected return value. What do we want sumOfList to return whenever it's invoked with this specific argument? And of course, 1 plus 2 plus 3 should give us 6. Below, I'm going to do another line break, and I'm going to run another example just to double check. So I'm going to do 3 of those symbols. Again, I'm going to do sumOfList. Again, invoke that function. Again, this is just a documentation, so we're not literally going to be invoking this function in this file, but the doctest module will do it for us. And then let's say another sample argument, I can do 5, 8, and 13, and the sum of those 3 values should be 26. And then I'll delete these empty lines here. And so here we have a docstring. And here you can sort of think of this as an assertion, right, in many ways. We are asking Python or validating, or asking Python to validate, that when it invokes sumOfList with this argument, we assert or we expect that we should get these respective return values, 6 and 26. By the way, this is an example of test-driven development, or TDD. The word test-driven development means that tests drive our code. What it essentially means is that we write our tests first. So here, notice before we actually started building out the implementation of sumOfList, we actually wrote the expected result of the function. We expected to take a list and we expected to return a integer, right? So we're declaring sort of the interface or the expected way that sumOfList will work before we actually write its implementation. And we're going to talk about later why test-driven development is a really good approach to writing code. But regardless, we can go ahead and write a custom solution. Now, we know that there is a sum function available in Python, but I don't want to use it here because I want to write code that is going to be custom that may lead to an error. So one very basic way that we can create a sum is by simply using a for loop over a list and then adding each number to a rolling sum as we move along. So for example, I can declare a variable called total and set it equal to 0. Then I can iterate with for every num in numbers, for every element. I can take my total and then I can add to it whatever is the current number that I'm iterating over. And then finally, at the end, I can go ahead and return the total, which should be the cumulative sum. Now, by itself, this is a function. We're not invoking it, so nothing is going to happen if we execute and run this file right now. So below, what I want to do is add some special code to use the actual doctest module. First of all, we're going to make sure that we're running this file as a script. So I'm going to use our familiar if the dunder name is equal to the dunder main string. We know this file is being run as the primary file. And here what I want to do is only in this scenario do I want to import doctest. which is our module. And then on our module, we have a function called testmod. All right, so what testmod is going to do is it's going to look at our docstring right here, and it's going to check for pieces of text that look like Python expressions. Here is an example of a Python expression. It is valid Python code. It is going to run this code, for example, on line number 3, and it's going to validate that what it sees, or what it gets back, is what it sees here on the line immediately below. So when I execute this, we're not actually going to get any output, and the reason we're not going to get any output is because all of our tests are passing. All of our assertions are valid. The sum of this list is equal to 6, and the sum of this list is equal to 26. However, what I can do to show you what this will look like when it fails is simply change our assertion right here to 25. This is going to add up to 26, but we are telling Python that we expect 25, so we're going to see a nasty terminal output right here. And if we scroll down, we can see here this idea of the expected versus the got, the value that we expected to get versus the actual result. We told Python that we expected a result of 25 when we invoked sum of list with these 3 arguments, or rather this one argument being a list of 3 values. However, Python is telling us that it got 26. And it's telling us that one of our 2 declarations, one of our 2 assertions is invalid. So you can see it says test failed. This is an example of us writing a valid test in Python. This is an example of us writing an assertion or a validation. Now, it's not with the primary module that we're going to be using, which is unit test, but this is still an example of a test. Now, you might be thinking, okay, this is simply an example of a typo for us, right? We accidentally wrote 25 when we meant to write 26. The real goal of tests, even though tests can sometimes go wrong themselves, the goal of tests is to make sure that your code is working as expected. So let's say that we wrote these tests, these assertions, and then we started writing our code. And here we added all of our iterative numbers to total. But let's say at the end I made a programming mistake. Instead of returning total, I accidentally returned num, which is our iterator variable. And in this case, it's going to represent whatever is the last number that we iterated over, in this case 3, and in this case 13. So the goal here is that we wrote tests that we know to be valid. We know that this is what the sum of these numbers is, and 26 is the sum of what these numbers should be. And thus, what can happen is whenever we write this code or modify it, we're going to be told by the output that, hey, I was expecting to get 6, but instead I got 3. And that allows us as developers to say, okay, well, I definitely know that 1 plus 2 plus 3 should equal 6, which tells me that the way that I wrote the code, the way that I implemented it, must be inaccurate. And then, of course, I'll go through the code, line number 8, 9, 10 looks good to me, and I'll realize, okay, my mistake is on line number 11, this should be total. And then what I can do is by simply running the file again, I make sure that doctest runs our tests again, and now we assert, and we can see without any output, we know that everything is passing. And that's really the whole purpose of testing, is we can validate that any new changes to our code do not break existing functionality. Imagine if we had a function that was 100 lines long. Now that's generally a bad idea, but imagine we did. And imagine there was 10 different paths or branches of execution that function could go. Think about how exhausting it is for you as a developer to try to get all of those 10 different paths checked, right? You have to manually invoke the function yourself, maybe put a print function here and there. It increases the rarity or the probability of finding an error significantly, because there's so many different pathways of execution. You forget which ones you've tested, which ones you haven't, right? With a test, it works very similar to what we have here in this lesson. We have a declaration or an assertion that when we do this, we expect this result. And Python, of course, runs a lot faster than we do, so it can run through 100 different tests and 100 different pathways of execution and validate that a function works as expected. So that's really all there is to cover in this lesson. I wanted to briefly introduce you to the doctest module to sort of give you an understanding of how tests work before we dive into the nitty-gritty details of using the unit test module. Now, why is doctest not a good idea for a real-life app? Well, the problem with this module is that it tends to be super literal when it's comparing results. So for example, it's going to consider a double-quoted string and a single-quoted string as unequal, even though they obviously are. So it's not that reliable. It's going to get into all these picky situations where it's going to say two things are not equal even though they are. We really need a more robust, well-built testing system. But the goal of this lesson is, again, to serve as a prerequisite to get us thinking about what a test fundamentally is. It is an assertion or a validation for a given piece of code. It's saying, Python, if you were to run this piece of code, here's what I expect you to get. Here's the value that I expect to receive. And if we write our tests first and then we write our code, we can let Python do the work for us. We can let the computer run and execute our code and double check that the way that we've we've built it out, is a suitable solution to get the expected results that we want. So hopefully this is giving you a picture of the purposes of testing. We're going to review a little bit more as we proceed, but finally in the very next lesson, we can dive into the unit test module and see how we can begin setting it up. So as always, lots more to cover, and I will see you in the next lesson.